Welcome to this sun-powered edition of PowerHouse. Today we're going to be talking about ways to implement solar technology in your home.
First, we want to talk about some basics. We all know the sun provides light and heat for our planet, but we want to know much more about how do we harness those rays and use them to power everything for our homes.
And Steve Gradanis from Alliant Energy is here with us today. And Steve, people have been using the sun for light and heat since we've been on the planet, right? But when did modern solar technology come into play?
There's a few different types of solar technology for making electricity. The one we see most commonly here in the Midwest is the photovoltaic solar module, which has been around since roughly the 1950s. Since that time, the wattages have continued to increase, the efficiency has improved, the cost has come down to now where we've reached a point here that the technology has evolved and the price has come down, that it's very economical to utilize this technology even here in the Midwest.
Steve, what are the main system components that are used to harness the sun into electricity?
The most visual components of a system are the solar modules themselves, which are the rectangles you may see out in fields or on rooftops. And you'll also see the racking system or the attachments that those modules are either affixed to the roof or standing in the field. What you may not see behind the scenes is some of the more electrical components, some of the wiring, the inverters, the main panel boards, and the meters that are attached to those systems.
Can you walk us through the process of how all of those components work together and really focus on those photovoltaic modules that we see?
Absolutely. Starting at the photovoltaic modules, inside each one, as the solar radiation hits that module, it's creating a DC current flow, creating electrons to move, similar to a battery where you'll have that DC, a plus and a minus on each module. What we do is we take those modules, connect them together, plus and minus, to create strings of modules, strings of DC, and we'll connect those together to aggregate that power, and then we convert it to AC electricity through the inverters, and we bring that out to the grid. The analogy I like to utilize is it's a lot like the leaves and branches of a tree. Each solar module out there in the field is like the leaf of a tree. It's collecting the sun's energy, and any one module is only a small component of the total system. But then behind the scenes, you have all those branches that are just aggregating that electricity together and putting it out onto the overhead distribution lines that you'll see throughout our communities.
So, I love that analogy of the tree, and we see all the modules. Steve, help us then again, how does that get from those modules then into that usable electricity? What's the next step in there?
So behind the modules, it's a lot of DC wiring. So that's bringing the power together, DC, similar to batteries. And what we do is we bring that up to our desired system voltage. On our larger systems, that's 1,000 volts DC. And then we start connecting those strings in parallel over and over and over again, as many times as it takes to determine the size of the facility we want to build. Then we take that DC energy and we need to convert it to AC, because that's what we plug into in our houses. And so that's the inverters, and there may be our small string inverters or large central inverters at our utility scale facilities.
Now, there are so many components to this. This goes much deeper than just driving by something that's sitting on the countryside. What is the general cost? Is it more as compared to creating traditional energy?
The cost continues to fall for photovoltaic electricity. I like to equate it to a cell phone or a computer. The technology is evolving so rapidly. If we look at some of Alliant Energy's facilities from just a couple of years ago that are 1, 2, 3, maybe 4 megawatts compared to the 50 megawatts and larger utility scale sites that we're working on today, the cost continues to fall both from the technology as well as the economies of scale of those sites. Again, to where it makes it very economical here, even in the Midwest, to build these facilities.
Steve, as we sit here late in 2022, what percentage of Alliant Energy's energy is through solar technology, and why is this so important?
As we're sitting here today, we are actually in final commissioning of about 250 megawatts of solar. And by the end of 2023, we're hoping to have more than a gigawatt or 1,000 megawatts of solar online, which is 50 times as much solar as we have in operation just today.
Why is it so important for Alliant Energy?
Really, it ties into our overall generation mix that we have. We are trying to provide the lowest cost, most reliable power to our customers that we can.
You know, Pete, thinking back to the beginning of PowerHouse, when we first started talking about solar energy and it was so futuristic, it really is exciting technology and it's fun to watch it grow so rapidly.
really is.
And we thank you so much for sharing all this information with us. You know, I can see why solar is so important to Alliant's overall energy generation.
Absolutely.
And the next time you drive by a solar array, you can say, I know how that works.
As of June 2021, the largest solar farm in the world was the Bladya Solar Park in India. It's spread across 14,000 acres and has a total capacity of 2.25 gigawatts.